Wow, over 500 milliamps of current generated from this motor. This is awesome. How does it work? Let's find out.
Have you really wondered how DC motors actually works? Like, how does it actually generate electricity? Because in rumors, I've actually been saying the rumor that DC motors are actually generators. They actually spin and it also generates electricity. But it's a rumor that have not been yet answered. It's a question that have not yet been answered. I know there's a lot of videos on YouTube answering this particular question, but I'm going to make it in my way. I'm going to be explaining how DC motors actually works. Then how does it actually generate electricity? By just spinning the knob. How does it generate electricity? It's a kind of crazy idea which I really need to talk about. So you need to stay till the ending of this video to get great insights. Let's go into the video. Now, firstly, before clearing the rumor on how electric motors or DC motors actually generate electricity or how it's actually related to generation of electricity, I'm going to first of all explain how DC motors actually work, just as I said in my Patreon. Then I'm going to be explaining the main theory on how it actually generates electricity, like vice versa. So let's go to that. So now in the DC motor, we have four main parts. These four main parts is actually what enables the DC motor to spin. Now, don't get me wrong, I'm actually talking about DC motor, not AC motors. Yeah, there's other type of motors such as the brush motor or the brushless motor, but in this video tutorial, we're only discussing about DC motor, nothing else, so don't get me wrong. Now, the four main parts actually inside the DC motor is actually the commutator, the stator, and the coil, and also the permanent magnet. Yes, there's actually a permanent magnet inside of this brush motor that enables the motor to spin. And that's actually a roll of coil. There's actually a roll of copper wire which is actually inside the motor, and also a commutator. A commutator is actually what changes the polarity of the motor inside, and the brush is actually what sends the electric flow from the battery to the motor. I'm going to be explaining more in this video, but first up, I just want to explain the use and the work of these components which are inside of the motor. So to get the main theory on how the motor actually works and the components which are actually built with the motor are actually built to make the motor to function, we are going to be opening up the motor. Not this motor, I'm going to be opening up this DC motor. This motor, I wish to open it, but it's kind of difficult to open it. So we are not going to be opening up this motor, we are going to be opening up this motor. Kind of look a lot rusty, but anyways, we still got to get the point on how it works. The rustiness does not stop it from having the component that make it works. So let's open it. I'm going to be showing the video down below. Oh my god, I'm really sorry guys, I really destroyed the brush, but anyway, the motor is not really functioning that well. I don't know if you can see it clearly. The brush is actually damaged, my camera can focus, so bullshit. Anyways, this is actually the brush. I'm gonna be making a video right now. This is actually the brush, and you can see it's kind of fumbled, but I'm so sorry about that. I was like drawing it to open it up, and that's actually fumbled the brush. But anyways, we are just getting the parts which are actually inside the motor, nothing more. I don't think this motor is going to be able to function again. It can be able to function, but with the brush so dismantled like this, I don't know if it'll work. Maybe it's not going to be spinning the way it used to spin before. Anyways, we got the motor inside, and look at the component chart. I'm going to be making a video about it.
Yeah, I spent a lot of time talking about it. Let's make it simple. Okay, now looking at the inner part of the motor of the DC brush motor, we can find the copper wire which I actually said in the other clip, and right there you can also see the stator. The stator is actually the magnet which are actually imputed into the motor for the motor to function, and we also can see the commutator which actually helps to swap the polarity of which the power goes into the motor, and obviously the brush is a very important role to send power to the motor. Yeah, the brush is actually what supplies power to the motor. Without the brush, you're not gonna make the fan to spin, stuff like that. So yeah, we need power to go into the motor, and there is where the brush comes in, and it's very important. You see, really short. The other video was really long, so I had to cut it. Let's go back to what we're saying.
Okay, without wasting much time, I'm going to be explaining how the motor actually works, but that's not the title of this video. But for kind of understandable sake, you need to understand how the motor works before you know how it actually generates electricity. So I'm going to be making that quick, really fast. I'm going to be making a different video on how it works. But yes, I'm still going to be explaining how it works, and you're going to get it. So yeah, just listen. Okay, firstly, before I explain how the commutator is important in the electric DC motor, I want to explain how the magnetic field actually works and how the motor actually spins internally. Now, we all know that we have two magnets side by side to the coil, as I actually said in the intro of this video. Earlier in this video, there are two magnets which are actually side by side to the coil, and I just made this as a diagram. This is actually a diagram, not a main picture. I just made this as a diagram diagram as the representing the coil which is actually winded inside of the motor. Now you're going to be asking me how does it works and how does the commutator actually comes in. Now this magnet is actually faced in north and south. You know that a magnet have two poles. That's the first thing which you really need to know. You know a magnet actually has two poles. Actually there's north and the south. The two magnets are not faced together. The two magnets are not faced the same. One magnet at one side is actually faced north inside and south outwards. Then the other magnet is actually faced south inside and north outwards. Now you're going to be asking me how does this actually spin the motor. Now this is actually a coil which is actually, I actually said recently on my earlier clips, I actually showed the internal coil. It is actually the internal coil. Now when this coil electricity flows through this coil, let me say I put in the electricity voltage of about 3 volts and I put positive here and I put negative right here. Now this electricity flows through this copper wire. Now you're going to be asking me how does it actually work. Now when electricity flows through a conductor or when electricity flows through a copper wire, the copper wire actually turns to a magnet and the copper wire starts releasing electromagnetic field. Thereby the copper wire will now have two poles, just like a permanent magnet. Actually said the permanent magnet actually have the south and north poles. So when current flows through this copper wire, through this conductor, it actually turns to a magnet and thereby have a pole. And in this case the upside is actually the north and the downside is actually the south. I don't know if you're gonna understand what I'm saying. The upside, which is actually facing us, is actually the north, while the downside is actually the south. Now I actually said in the intro of this video that unlike poles actually attract and the same pole actually push forward. Just to clarify you right here, I have two magnets right here and the two magnets have different poles. Let me see, here is north and here is south. I don't know if you can see it very clearly. And here is north and here is south. The same poles, like poles, actually repel. It actually causes the magnet to repel. But if here was south and here was north, it will actually attract. Let me draw it for you. If you join two magnets with the same poles, is actually going to repel. But if you join two magnets with different poles, it's actually going to attract. It's definitely going to attract. So now you can see the second magnet right here. This is actually north and this is actually south. This will actually cause them to attract. But if you face the magnets with different the same poles, it's actually north, it's actually going to repel. Now when current flows through, it actually said that the upside is going to be north and the downside is going to be south. And you can see the two magnets which is actually here. South is facing inside and north is facing inside. They know why they set it that way, so that it will enable the copper wire and the motor to actually function. Anyways, when the current flows through here, I actually said that unlike poles actually attract and like poles repel. So this coil will be forced to turn over to south, because I actually say unlike poles repel. So I don't know if you remember, I actually said the upside is actually the north and the downside will be actually south. Now it will be forced to turn anti-clockwise to south, because I actually say unlike poles actually attract. Now you're gonna be saying it's just going to turn clockwise anti-clockwise direction. What next? It's going to be stopped right there. It can move. That is where the commutator actually comes in. The commutator actually helps to change the polarity of which this conductor is actually connected to the power supply. Now let me say it's actually connected to the power supply. This is actually positive and this is actually negative. The commutator have two sides. The commutator have, is it two sides or three sides? It actually helps to change the polarity of which this conductor is actually connected to the power supply. Now the commutator actually helps to change the connection to power supply. To here will be now positive and here will be now negative. Thereby this does not matter again. Thereby, as this changes the polarity of which the conductor is connected to the power supply, it actually changes the poles of the magnet. It actually changes the poles of this magnet which is actually generated here. Now the upside is not going to be north again. The upside is now going to be south and the downside is now going to be north. I don't know if you understand what I'm actually saying. The commutator actually helps to switch the polarity of which the coil, the conductor, is actually connected to the power supply. Now what happens? The upside is actually south right now and the downside is actually north. But I want you to understand something. I said that the first time the pole of the electromagnetic coil was actually north and south. So notice when this coil actually turns anti-clockwise direction from like this to like this, now the downside, which is actually south of this demonstration, the downside which is actually south is actually facing up and the north is actually facing down. And I actually said unlike poles attract and like poles does not attract. So when this coil actually turn anti-clockwise, the downside is now actually facing up, which is actually south. It will not turn again, because unlike the same poles does not attract, because up is now south and the magnet right here is also south. Same poles does not attract. That is why the commutator helps to switch the polarity of which the coil is connected to the power supply, thereby making the coil to be north again. This upside is now going to be north and the downside is going to be south, and the rotation continue. This magnet and these two magnets is actually what helps the rotation to continue. So I hope you get my point. When the coil is firstly powered, the upside is going to be north and the down is going to be south, just as I demonstrate right here. But when the unlike poles actually attract to this magnet, it actually turns anti-clockwise. This makes the downside, which is actually south, to face up, and it will not attract because the same poles does not attract. Only unlike poles actually attract. So when the commutator now switch the polarity of which the coil is connected to the power supply, the pole actually changes back to north and south, just as the way it will attract back to the magnet, the permanent magnet. Okay, I hope you understand what I actually explained back there. If you don't, let me know in the comment section below and I'll answer to you very quickly. Now, I actually made some carvings right here so that you can be able to understand it much better. I made some carvings of how the magnet actually looks inside the motor. Now, considering these two paper as a magnet, it has two poles, which is the north and south, and these poles also this magnet also really actually have the north and south also. And this is the coil which is actually in the center right here. This is the coil which actually carved out, and the coil which is actually powered to the power supply. So this is just the motor schematic. This is just how the motor is in the DC motor. I just made some carvings so that I'll explain it much better for you guys. So this, considering these two as the permanent magnet, and this is the coil which is actually power, and this is the coil which is actually inside of the DC brush motor. Now when power goes into this coil, it's actually changed to magnet and start producing electromagnetic induction. Now it now have poles. Now the upside is actually south and the downside is actually north, as you can see right here. So now I actually said unlike poles attract and the same poles does not attract. So this south will not be forced to attract to this north of this permanent magnet right here. As you can see, the south will not be forced to attract to this permanent magnet, making it to turn anti-clockwise direction. I don't know if you're understanding me. It will now be forced to turn like this. Now you can see that now it has turned anti-clockwise direction, but these poles are now the same. Now the down was actually north and the up was actually south, but now it has turned anti-clockwise direction, making the downside to face up, and now the downside is now actually north and north. North does not attract. So the commutator is actually what helps to switch the current of which it goes to the coil, switch the polarity of which power goes to the coil. Now when it switches polarity, this actually changes the pole of which the coil is. Now this pole is not going to be north again, it's going to be south, and the down is going to be north. Thereby it's going to be south and north, thereby making it to attract, because I actually said unlike poles attract. So I'm just explaining it with this particular one magnet so that you won't get confused. I don't want to involve the two magnets, but the two magnets is actually what helps the rotation. The same thing which happens here, that's what happens here also, but I'm just explaining only on this magnet so that you get the main point. So I hope you understand what I'm actually talking about. This is a quick 3D model on how it actually works inside, but also if you want to get the main animation on how it actually works to get more understanding, I got a video which I really love and got interested in, and go check it out. His name is Joe Owen. You can check it out and he make a very good explanation right there. Let's go to what you're saying. Okay, now the big question now lies on how does this motor actually really generate electricity if you spin the shaft, which is actually right here. How does it actually generate electricity? How is it possible? I've actually explained how the motor actually works, or how it works internally and stuff like that, and you've got the full breakdown tutorial, but that's not why you click this video. You click the video on how the motor actually generates electricity. So here's how it works. When you spin the shaft of this motor, the shaft is actually tied to the copper wire. As I actually said, I opened the other motor in the last clip, and you can see that the shaft is where the copper wire is actually winded on, and there's where the copper wire is actually winded on. So when you turn the shaft, when you spin the shaft, you actually spin the copper wire, and you have to bear in mind that the copper wire is actually close to the magnet. And I actually said that when you power the motor, it's actually react to the magnet to actually spin the motor. In other words, if you spin the motor, you're going to generate electricity. That's enough to tell you, and that's enough to twist the brain. You need to put in power into the motor for the motor to spin for you, and if you spin the motor is actually going to generate electricity for you. Okay, now that's by the way. Now how does it actually generate electricity from this motor? How does it actually generate electricity? That's the main question which you need to know. So when you spin the shaft, actually spin the copper wire. When you spin it to a particular speed, the copper wire actually cuts through the magnetic field which actually actually generated by the permanent magnet, because I actually said there's actually a permanent magnet which is actually inside the motor, actually cuts through the magnetic field which is actually generated by the permanent magnet, whereby the magnetic field which is actually generated by the permanent magnet is now induced into the copper wire and actually cause a force and charge, thereby moving the electrons, thereby pushing the electrons which is actually inside of the copper wire, and this actually creates a current flow, which is the electricity. This process is actually called induced EMF. When you power the motor and with a power supply at the two terminals right here, and the motor is actually spinning, the motor actually creates a back EMF. Now this back EMF is generated whereby reducing the current of which the motor is actually drawing. So when you actually power the motor for the first time, the motor is gonna draw a lot of current, but when it's actually full speed, when it's actually at its full speed, it's actually draw lesser current because of the back EMF which is actually happening inside, because it actually generates electricity for himself. It's actually power itself a little bit, so it does not need your input power supply anymore. For that starting time, it actually need it, but when the coil actually starts generating electricity, it's kind of powering itself a little bit and draws less current. So that is the one thing which you have to know in mind when you power up the motor. Is actually generating the back EMF, but when you spin the shaft, it's actually creating the induced EMF, and this is induced by a permanent magnet which is actually inside of the motor. Hi, so I just want to say thank you very much for watching this video from the beginning to this point. I know you've got a lot of interactive knowledge about DC motor, why is it generator, how does it works, and everything in general. I really appreciate you. Thank you very much for really watching this video. I really appreciate you. If you like what I actually do, though, forget to hit the like button, subscribe to my channel, and also support me on Patreon. There is an offer which I'm offering on my Patreon, so you can join my Patreon for 90% off on your first month of joining. Like if you join for the first time, you'll be off with the 90%, so you have to only pay 10% instead of 100%, which you're normally going to pay. So you're going to be charged 90% off on your first month. I'm going to be pasting the promo code in the comment section of this video, so do all the check in the free comments and join my Patreon for free. I really appreciate you, and I'll see you guys in the next one.